Medical volume data is usually explored on monoscopic monitors. Displaying this data in three-dimensional space facilitates the development of mental maps and the identification of anatomical structures. Using augmented reality could further enhance these effects. However, conventional interaction methods, like mouse and keyboard, may no longer be applicable in this environment. To this end, a user study comparing 4 interaction techniques with respect to both clipping and windowing tasks was conducted. Image data was directly displayed on a phantom using stereoscopic projective augmented reality and direct volume visualization. First, a concept based on hand gestures was implemented using the MICCAI gesture control armband for gesture recognition. Using direct kinematics, data of 2 inertial measurement units attached to the user's wrist and upper arm was used to calculate the user's relative hand position. Another technique was based on foot interaction. Gestures were recognized by attaching an inertial measurement unit to the user's foot. Lifting and lowering the forefoot activated the manipulation of parameters, which were then changed based on rotations of the forefoot around the heel. Since surgical navigation systems are commonly used in image guidance, a third concept enabled the manipulation of exploration parameters by mapping them to the position of a tracked surgical instrument. Mode activations were again performed using foot gestures. Finally, a controller-based method using an HTC Vive controller was implemented. Manipulation modes were activated by pressing and holding buttons. Movement of the controller in space was then mapped to changes of exploration parameters. Participants were able to complete both tasks with all interaction techniques. However, results suggest advantages of gestures based on motion-sensitive devices in terms of reduced task completion time and less subjective workload. This work presents an important first step towards a surgical AR visualization system enabling intuitive exploration of volume data.